Okay, I kind of wanted to walk through each one of the reactions that you're going to have on your test. I know that all of these were covered within the different chapters, but that way you won't have to go back through all the videos if you just want kind of a quick review of those different kinds of reactions. So the first one we're going to go through is a precipitation reaction. So they will give you the starting materials, and then we know it's going to be a double replacement. So those first two terms switch places. So the PB is going to go with the SO4. And I'm getting those charges off of my periodic table that has all of the charges on it for me. So the one that looks like that. And I know here, since there was two of the NO3s, that this is a +2. And then my SO4, I know on my periodic table up here, my polyatomic ions, is a -2. Those add up to 0, so that's a good formula. Then the Li is going to go here, and it's going to go with the NO3. So I look at the charge for Li, and I look at the charge for NO3, which is on my sheet. So, for example, here is NO3, it's a negative, and Li is a positive. And so those two add up to 0. Then the next thing I need to do is I'm going to look at those phases. So you have a table that lists all the solubilities. So this is the one that I'm looking at, and it said sulfates are soluble unless they're with one of these things. So I have a sulfate that's with lead. So that means this is not soluble. So this is going to be an S for a solid. And then if it's Li, that means it's soluble, or NO3, both of them are soluble. So that means this is soluble, which means AQ. Then I want to balance my equation. So 2 Li's, 2 Li's, 2 NO3's, 2 NO3's, 1 PB, 1 PB, 1 SO4, 1 SO4. So that would be my total balance equation, and it includes all the phases. So a couple important things: make sure you make the correct formula out of those two ions by looking at their charges. You can't just drag this 2 over with you. You have to make a new formula out of those compounds. And then it's very important, if you're looking at those phases, that you use your solubility table. Okay, for a neutralization reaction, this means an acid plus a base makes water and a salt. Okay, so I have to make water. Water is H2O. Water is a liquid. Now the salt is whatever things are not the H's and the OH's. So for me, that's the Na with the SO4. So Na, it's a plus, SO4, 2 negative. And again, I'm getting those off of my sheet. So Na is a plus, and then I look over here and I find SO4, and it's a -2. So these don't add up to 0, so I'm going to crisscross. And then I need to look at my solubilities to determine the phase. And anything in column 1 is soluble. Even though I have sulfate, it's not one of the exceptions. So this is going to be soluble, which is AQ. So even though, like an S in here, S doesn't mean soluble. S means solid. And AQ means it dissolves. That's soluble. So 2 NAs, 2 NAs. I have 1 SO4, 1 SO4. I have 2 H's, and 2 more is 4 H's. So I better have 4 H's. And then 2 O's that aren't part of my SO4, and 2 O's. Okay, next one is acid plus carbonate. So acid plus carbonate makes water, carbon dioxide, and a salt. So I'm going to make water. Water's a liquid. Carbon dioxide is a gas. All right, my salt is whatever I haven't used yet. So I've used C's and O's, and I've used the H's. So Na with Cl. And again, I don't drag this over here. And a lot of times students are confused. They say, well, sometimes you take this CO3, like over here, I took, up here, I took the NO3 and I drug it over. That's because this is a polyatomic ion. I have to keep that polyatomic ion together. Same thing here with the SO4. I take it all over. But Na is just a regular ion. So I have to make a new formula out of Na and Cl. And that's a plus and a minus, so that adds up to 0. And then, since it's in column 1, it's soluble, and chlorides are soluble, and it's not one of those exceptions. So this is soluble, which means AQ. Let's see. 2 NAs, 2 NAs, 2 CLs, 2 CLs. I have 2 H's. Here's 2 H's. Get our 2 CLs. I have my 2 NAs. I have 1 C, 1 C. I have 3 O's, and here's 2 and 1, which is 3 O's. Okay, last one is a combustion. And on your test, it has this part listed, and it puts like question mark, question mark, question mark. So basically, it gives you the formula. You just have to balance it. And oxygen's a gas, carbon dioxide's a gas, and water's a liquid. So I'll try 4 carbons and 10 hydrogens. So 5 times 2 is 10. That gets me 4 times 2 is 8 O's plus 5 more is 13. Nothing times 2 makes 13. So I gotta double these numbers. Put 8, 10, 2. So 4 times 2 is 8. So when you end up with that even odd, you double what you have. So I had a 1, a 4, and a 5. I doubled them. So 8 carbons, 20 hydrogens, 20 hydrogens. Now I have 8 times 2 is 16 O's plus 10 more is 26, which means I have 13 oxygens. All right, so there you go. There's a quick review of the kinds of reactions that you're going to see on your test.